Hello, everyone. Today we're moving on to day 2, which is 7-2 geometric mean, or the mean proportional. Geometric mean, the means are equal. So in my proportion, what's on top of one is equal to what's on bottom of the other. So to find the geometric mean of two numbers, 4 and 9, I set up the proportion where it's the first number over x equals x over the second number. I solve this by cross multiplying, so I get x squared equals 36. And then remember to get rid of x squared, I take square root, so it's square root of 36, so it's just 6. Here, again, I cross multiply, so I get x squared equals 4 times 18, which is 72. I then take square root of both sides, so it's the square root of 72, which I'm going to round to the nearest tenth, which is 8.5. So I want you to pause and I want you to try example 1. So when I'm finding the geometric mean between 5 and 45, it's 5 over x equals x over 45. I then cross multiply, so I get x squared equals 5 times 45, which is 225. And the last step is I take square root of 225, which is 15. Now, one of the uses of geometric mean is when we have very special right triangle. So special cases of similar triangles. I must have a right triangle with the altitude drawn to the hypotenuse. So that means I have a right triangle, my large triangle ACB, and from the right angle, I draw an altitude, which always forms another right angle. This scenario, which is very important and very special, always gives me 3 similar triangles. So my largest triangle, ABC, is similar to, so the big blue triangle, ABC, is similar to this red triangle, ACD. So notice that A goes with A, and that D is my right angle, which goes with C. And those are both also similar to CBD. And those are all 3 similar by AA, because ABC and ACD share A, and they both have a right angle. Then ACD and CBD share D, and C is congruent to A in that case, but it's really because the big one shares B. So that special case gives me 2 very important ratios, which are Hills and SAS. So in Hills, the H stands for the hypotenuse of the big triangle, and L is the leg of the big triangle. S is a part of the hypotenuse of the big triangle, and it's on the same side as the leg. For SAS, A is the altitude of the big, and S's are parts of the big triangle. So let's set up some proportions using these. So I'm going to redraw ABC here. So we had triangle ABC with altitude CD. So when we're doing hills, H in this problem will always be AB. And now we can do it 2 different ways for the 2 different legs. I can do it for AC equals AC, and then it's going to be to AD because that's what part the leg AC is closest to. Or I can do it as the whole hypotenuse again, and this time I can do the other leg, BC, is equal to BC, and this time it's going to be BD because that's the side it's closest to. So those are my two possibilities for hills. SAS only has one possibility, which is my first segment, which is AD, to the altitude. The altitude's the line in the middle, CD, is equal to CD over DB. This one way you can remember it is it kind of makes an altitude symbol, makes a right angle symbol. We can use these proportions to solve for missing parts of a triangle. So, how do I know when to use hills and when to use SAS? If I have an altitude, I'm going to use SAS. So letter A, I do not have the altitude, so I am going to use hills. So it's hypotenuse to leg, as leg is to the segment. So again, remember, hypotenuse is the whole bottom. So the whole bottom in this case is 12. So it's 12. And then I'm looking for Y. So that's my leg, because that's the leg in the big triangle, equals Y over. Now I'm going to use 3 because 3 is the closest one to Y. And then I solve that by cross multiplying. So I get Y squared equals 36. I then take square root of both sides, so Y equals the square root of 36, or 6. Letter B, I'm looking for the altitude. So that means I'm going to use SAS. Segment 1 to altitude equals altitude to segment 1. Remember, my segments are how the hypotenuse is broken up. So I'm going to do 4 is to x, as x is to 12. I cross multiply, I get x squared equals 48. I then take square root of both sides. You can round to the nearest tenth again. So the square root of 48 is 6.9. I want you to pause and try problem C. So here I have the altitude. So I'm going to do segment 1, segment 2. So it's SAS, segment 1 to altitude equals altitude to segment 2. So it's 2 is to 3, as 3 is to x. I cross multiply, I get 2x equals 9. I divide both sides by 2, and x equals 4.5. So that's the end of our video. If you have any questions, please ask tomorrow in class.